Square cube law for rockets. I've heard that the square cube law applies to rockets, but I haven't seen any examples showing exactly how, so thought I'd make a video. So that's just what it means. It's a square in the cube. So here's your rocket. I'm going to start out making things really simple here with just a simple cube. The thrust can only come out of the bottom, so the thrust is dependent on the area of 1 times 1, thrust to weight ratio, 1 squared. Then the weight is going to be 1 cubed. That's going to be 1 squared over 1 cubed. So it's just 1, and that is your thrust to weight ratio for a rocket that could fly if it looked like a cube. If you make something twice as big, it makes it 8 times heavier. I guess I should say if you make it twice as tall, it'll become 8 times heavier, because now your cube has to go up twice, times 2 this direction, times 2 that direction, times 2 deep. So it doesn't matter how much fuel you carry. You can have a huge amount of fuel, but the thrust is dependent strictly on the area, that little area right there, because that's where the propellant shoots out. So the thrust will just be 2 squared, 2 times 2. The weight will be 2 cubed, so it'll be 8. 1, 2, 3, 4, 5, 6, 7, 8. So 8 cubes. 2 squared over 2 cubed equals 1/2. In other words, you multiply by 2, and then you change your thrust to weight ratio to 1/2. That's just what I wrote right there. And it gets, these numbers get even smaller when you multiply by larger numbers. So right here, let's make our cube, or make our rocket 10 times larger. 10 times 10 times 10. The thrust is going to be 10 times 10, 10 squared, which will be 100. And then the weight will be 10 cubed, 10 times 10 times 10. So you end up with 10 squared over 10 cubed. This is our square cube law. Comes out to be 1/10. So if you multiply the size by 10, you end up with 1/10 of the ratio. If you multiply it by 3, you end up with 1/3 of the ratio, etc. This also works if you want to have a rocket that's more of a rocket shape instead of a cube shape. So let's say it's 1 by 1 by 10 are the dimensions of your rocket. The thrust will come out of a little area that's 1 by 1 right there, so 1 squared. The mass will be 10 times 1 times 1. 1 times 1 times 10, you get a 1 to 10 ratio. Let's say this is what we need for our rocket to fly. The thrust to weight ratio will be 1 to 10. Let's make our rocket 10 times larger now, times 10. So now we're going to have 10 by 10 for the thrust, 10 squared. Then the weight will be 10 by 10 times 100, because I multiply that 10 by 100 right there. That 10 squared is 100. 100 divided by 100 cancels. This becomes a 1. You end up with a 1 to 100 ratio. So if you multiply by 10, then you decrease your ratio to 1/10 of the original ratio. Just like I said up there, if you multiply your mass by 18, then you'll decrease your ratio to 1/18. See my other video where I went into detail on the square cube law and how it applies to things that fly and climb and whatnot, if you are so interested.